Hello students, today we are going to discuss about half wave rectifier. Before understanding what is half wave rectifier, let's understand why we are going to discuss about half wave rectifier. As we have already discussed about diode and its different types, such as when a PN junction diode is forward biased and reverse biased, we have seen what will be happening in a circuit. So actually we can say half wave rectifier is an application of a junction diode. So first let's understand what is rectifier, then we'll see why we are calling it as half wave rectifier, is there a full wave rectifier, etc. So as we have learned when we were discussing about diode, we know that a diode will be conducting only when it is forward biased, right? When a PN junction diode is in forward bias, we know what will be happening. We know that the width of the depletion layer will be getting decreased because the applied external voltage is in the opposite direction as the current of the depletion layer, right? So the width of the depletion layer will be getting decreased. As it is getting decreased, the current will be flowing or the conductivity will be getting increased. So we know that the current, if we apply a alternating voltage across a diode, the current will be flowing only when the PN junction diode is forward biased. So we can use this to rectify the alternating voltage. So the device which is used to rectify the alternating voltage is called a rectifier. Rectifier can be of two types. One is half wave rectifier and the other thing is full wave rectifier. We will be discussing about full wave rectifier later. First let's understand what is a half wave rectifier. Okay. So as you can see over here, this is the diagram of a half wave rectifier. Here you can see I had given a external alternating voltage to a transformer which is having a primary and secondary winding. Here you can see 2 point which shows in which direction or how the diode is biased. Here you can see a PN junction diode, here it is a load wherein we are going to get the output. As it is in forward bias, when the alternating voltage is flowing through the primary winding, as we have already learned in our previous chapter that due to electromagnetic induction it will be flowing towards the secondary and it will be flowing like this. So the diode is in forward bias, it will be flowing like this. So when we are talking about the VI characteristics or when we are talking about the output, here if this is the input, what kind of output we will be getting? Because the current will be flowing here and when it reaches point A, the diode is forward bias load, and when it reaches the point B, then the diode will be converting into reverse bias, right? Because now the current is flowing in the opposite direction, right? When we are comparing with the transformer. So what will happen? The diode will be showing the characteristics of a reverse bias PN junction diode. So there won't be any conduction. So if this is the input, then we can say that the output will be only half wave, which means we won't be getting a full output. We will be getting only half output, right? So here by using a half wave rectifier, obviously we can rectify the alternating voltage from a PN junction diode, but at the same time we are not getting the exact output which we are waiting for or which we want. We will be getting only half of the input which we are given. So then people started to think how we can regulate this output to convert it into a full wave. Then they came up with the idea, if here we can see only one diode is added. If we are adding another diode, then it will be when this point is forward bias, this will be reverse bias, and once the current reaches over here, this will be reverse and this will be forward, which means we will be getting a proper output when we are using a full wave rectifier. So now the working of half wave rectifier, it's clear for you. First we will be giving our input AC voltage. By using a transformer, it will be going to the PN junction diode, and from XL we will be getting the output. So what is very necessary to remind in a half wave rectifier is, here it will be rectifying only half the input. It won't be rectifying the whole input, because once the current is flowing, only one diode is used. So by using one diode, we can rectify only one time, which means only one cycle will be getting rectified. So this is how a half wave rectifier works. Now let's understand the working of a full wave rectifier. Now let's discuss about a full wave rectifier. As we have discussed in a half wave rectifier, the only disadvantage or only limitation in a half wave rectifier is only one part of the input was getting rectified, right? So people started to think, if we want to rectify both the cycles of an input wave, then what we have to add? Then they came up with the answer that if we are adding one more diode with the same half wave rectifier, then because diode is the one which is rectifying, right? So now if the input is going like this and when it reaches the point A, obviously B is at reverse biased. So we will be getting here one cycle of output will be getting rectified, and once it reaches the point B, or from point B if it is going back, then here when it reached over here, what will happen? This B will be coming into forward bias from reverse bias. At that time the point A or the diode number 1 will be reverse biased. It's very simple. If D1 is reverse biased, then D2 will be forward biased. If D2 is in reverse biased, then D1 will be forward biased. So when we are discussing about the input and output of a full wave rectifier, we can draw the characteristic of Vi like this. If we are giving an input cycle like this, then here both the cycles, that is the upper side and the lower side, will be getting rectified, which means we will be getting an output like this, which means the cycle number 1 full wave will be getting rectified, which means here also this part also will be getting rectified, this part also will be getting rectified. So we will be getting a proper output when we are using a full wave rectifier. So this half wave rectifier and full wave rectifier is one of the application of a PN junction diode.